the questions themselves are going to be the easiest questions you've done here, right? This says what's the derivative of the integral from 1 to x of this function. It's going to be just the function itself, right? We're going to do this two ways here. You probably will gain an appreciation for those two fundamental theorems of calculus, two versions of it, later as you think about it, right? It's not going to be, I can sit here and describe it a million different ways, but it takes time to understand it, rethinking it. We're going to do this the long way first. Long way. Derivative of integral from 1 to x of t dt. I know you don't like it because we're using t as the dummy variable. It's not very often that t is a dummy variable. Today it has to take the role of, usually it's got the lead role in this here, right? This x over here. Right now it doesn't. It has just this dummy role. Don't get confused because of that. Here's the main variable, right? You see, you can tell right here. Yep. Oh. Yes. There's no small parts, only small variables. T doesn't like to take the role of the dummy variable, but what's that? Every variable is equal, yeah. Exactly. A variable is a variable no matter how small. So let's leave this part of it for a second here. Let's just evaluate this. You're not going to get a number for it because it's got a variable here, but you are going to get something, right? So we're going to put this in brackets, evaluating that. First of all, you need an antiderivative of that t. 1/2 t squared. So we're going to write every 1/2 t squared evaluated from 1 to x. I will have to continue this down here, except we'll go up there. I can't. This is in the middle of a page. Can't extend that there. Okay, derivative with respect to x of. We will do that later. I didn't want to make you feel bad at this point. 1/2 x squared minus 1/2 1 squared. That 2 kind of has problems there. What's in the brackets here if we 1/2 x squared minus 1/2. If we do the derivative of that, what's the derivative of that? Which is x? It's x, which is also known as x. Okay, the short way. The shortcut is the derivative with respect to x, if this is the variable of this function, is the function itself evaluated for that variable. The function is t here, right? Just a variable all by itself. You just put the x in instead, right? So the shortcut is x. The shortcut is x. So we're gonna use the shortcut for this. You can do the long cut and do it that way if you want. You can use the antiderivative of this because it's just so darn easy. Let's do the long cut here. You get the idea. Okay, what is it going to be?
3x squared minus 2x.
Why is this going to have?
Because when you do it the long way, that number comes out to be a constant.
This is a constant. This doesn't add to this area. This doesn't affect how fast the area is changing, that 5. That's where the area is starting, right? Let me show you the visual representation of this. 3t squared minus 2t looks something like this. It doesn't really, but there's some curve, right? Starting at 5 and going up to x here. This looks nothing like it, but starting at 5 and going up to there, This is the one that moves. This is the variable, right? This thing moves. That's what's changing the area. That's why it's the only thing involved there. And the rate that the area is changing is how high that function is. The 5 doesn't have anything to do with it because it's a constant. It's not a variable. Okay? Like what you said before, what if the lower limit was the variable? Then that's the one that would affect it, and the upper limit wouldn't matter, right? And you probably would realize that it would be negative then if you flip those around, right? Okay. It's the rate of change of this area underneath this curve. Okay? Because this is the area underneath this weird curve. The rate that it's changing from 3 up to x. X is the variable, it's the one that's moving, but the rate of change is only affected by that, where that is. It's affected by the height of the function for whatever value that is. The 3 doesn't affect it. Okay, so this is going to be, the short way is just 1 minus sine squared x.
Can you simplify that?
You could, but
You can make it cos. Cos squared x. No, just cos. No,
you want to make it cos x to confuse people?
That's the answer.
Oh, identities.
Identities. That's just doing that for the sake of doing that.
I got it. You don't think of the square root.
Are we continuing with this here? I told you this is the easiest questions you've ever seen here, right? But the concept involved is important. This is just switching it up here to let t be the important variable for once.
Cool.
You have to look here, right? This is the variable. If it says derivative with respect to t, that's the variable, right? Minus t squared. What are we knowing about here?
Oh my god.
Oh my god.
We got so many variables.
What? This is what you're thinking of here? Are you knowing about one up ahead? I can't remember what's up ahead here.
No, number 8.
Number 8.
Number 8.
Oh, yeah.
But I already did number 7, and I haven't checked the answer. Just wanna check.
Do it the long way.
Got it correct. I got number 7.
Okay, well you can do these.
I did the number 7 with just looking.
What?
I didn't do the long way for number 7.
No, do the long way for this.
What was number 7? What's the answer to 7?
What?
Negative.
What?
Negative.
It's just negative.
Oh, sorry. That was one that's reversed. Yeah, because you can take any integral and you can say this is the derivative. Whoops. This is the derivative with respect to x of minus integral from 3 to x. Right? You can always switch it around. Right? It's just going to be that as negative, right?
I just did that so well.
Yep. If it was from negative 3 to x, well then you couldn't switch it to positive. You couldn't change from 3 to positive 3 like the integration. The only reason you could switch this to a negative integral is if whatever the change is from 3 to x, it's negative the other way, right? But if you switched it to negative 3, it'd be a completely different value. So, what are we talking about here? Do this the long way. Remember that this is a function here. You could change this to a u, right? Let u equal x cubed.
Is it just x cubed?
Yes. No, it is not, because you got to solve it the long way.
Do it the long way.
And you get the right answer.
This is a function that involves. It's like a chain rule function, right? It's a function of a function. Okay, let me say this, right? You know how to do this when you have a function that's an integral, like from 1 to x, and you also know how to use the chain rule, right?
I don't know how to explain it. Like, how can you generalize that? Because I don't think you can.
Maybe just show us up there.
I want to hear some possible solutions here.
Impossible, Kyle.
What?
No, it's not impossible. I didn't say I want to hear some impossible solutions.
Impossible. I can do it. Nothing's impossible.
But
Oh, I gotta stop it here. You